Here's an early rotary actuator that was for a 5-inch disk drive, and the magnets are in the back here. It's got the voice coil. This is all frozen up now, but this had square wire, ceramic magnets. The gap that the flux is in is right through here. This is magnetic. The coil that moves back and forth here is like a coil, voice coil, and I say voice coil, that's the term we called it, like in a speaker. You run current through it and it moves back and forth. You use square wire so you can get a little bit extra number of turns in there. Pack a little bit better than round wire. And the preamp for the recording heads is right here. There's another IC here, but the recording heads were down here on these flexures. This is really old stuff, probably late 70s, early 80s, for a 5.25 inch, 5.5 inch disk drive. There's a spring on here that prevented the unit from hitting too hard. Hit the crash stop. This bolted on. Anyways, this is an early 5.25 inch, 5.5 inch disk drive, 130 millimeter rotary actuator. And this one went underwater in Katrina, so it's pretty bad shape. I had this around. It's just in the junk pile. I wanted to document it. But I'm not sure if this is from a Pertec or a CDC drive. But it's an early 5.25 inch, 5.5 inch disk drive. Looks like it had 1, 2, 3, 4 heads on it. Probably in just, sub 50 megabyte range, maybe 10 or 15 megabytes in that era. This thing weighs many pounds, probably 2-3 pounds here at least, with the magnets. It's got non-rare earth magnets. It's just got old ceramic magnets. It's got this is all iron into 3 pieces. These are the ceramic slugs that are in there that are glued in place, and it rotates about the bearing assembly right here. This is all machined out actuator, because this was a prototype actually. So this wasn't a production unit at the time that I've got that. That's why I have it. It was in a junk pile from a place that I consulted at. But on this particular unit, when it was being built, it has a triangular structure through here because we were working on the vibration aspect. So we have a very broad piece of aluminum here, and we had it triangular here to keep the strength up for moving up and down. And in the other junk pile, there was many different types of aluminum assemblies here because we were working on the vibrational aspect. Because when you drive this thing like a speaker at certain frequencies, this whole thing is going to dance around, and you don't want it to do that. So what happens in design, you use some CAD, finite element analysis. A lot of times you end up just building many different types of prototypes list like this as far as the shape of the beam, and you go ahead and actually put an accelerometer on here, a very, very small one. I think it's the 2222 type, or the 22C accelerometer by Endevco. It's a little bitty picomin type, and we put it on here that lightly loads it, weighs a fraction of a gram, and you do vibration testing where you feed this with a sine wave and you slow increase the frequency, and then you look where this thing kind of goes crazy. Then you end up building another version with a different type of beam on here. So your goal is you want to make this thing have very little mass. So you say it has zero mass and has no vibration, no resonances in it. You're always going to get a resonance after a couple kilohertz. So what you want to do is you want to push that out farther so you get a more high performance design. So you end up through CAD and through brute force making many different models, and you physically build these up and you go through and test them out so you can try to get the inertia down by using low mass And you also want this thing not to be moving around in the wind, which causes seek errors and things like that.